get a mic?
Yes.
I'd rather get a mic.
You want to hold
Yeah,
it over?
you can put it around. Yeah. Hello? Okay, so we're going to present you the Open Academic Analytics Initiative, kind of initial research findings, I would say. As you see, there's a bunch of people there. We're actually three, so we're going to crowd you in a certain way. I'm Eitel Lauria. I'm the analytics lead for this project from the School of Computer Science and Mathematics. Let me introduce this project. What I'm going to do is kind of introduce the project briefly, then I'm going to allow my colleagues to present results. This is an initiative supported by the NGLC grant, funded by the Bill and Melinda Gates Foundation and the Hewlett Foundation. It was an 18-month period project. We seeked 18 years, we didn't get it. That's a joke. We began in mid-2011. We have pretty much completed the project. The project had as a goal the creation of an early alert system that had the purpose of, at early stages of the semester, detect students that were at risk of either failing the course or not completing the course, and subsequently deploying intervention strategies on these students with the purpose of enhancing their chances of success. We based this project on an open source approach. We created an open ecosystems for academic analytics. For this purpose, we use the Sakai collaboration and learning environment. Sakai, probably most of you know. It's an open source, very popular course management system, which in this case is implemented at Marist College. We use the Pentaho Business Intelligence Suite to develop our predictive models. In particular, we use Weaker, which is a component within Pentaho. We released our predictive models under Creative Commons license using PMML, Predictive Modeling Markup Language. And we've collaborated with other vendors, namely IBM, SPSS Modeler, just to test the portability of these models we had created across software platforms. The initiative had several research questions. The first one is, well, of course, how good are these predictive models at detecting students at risk? We're also interested in how good this, really, which were the best model predictors within these predictive models we had created, and for this purpose we used different data sets, pretty much similar in a way to what the previous presentation did. We used student attitude data, we used student demographic data, but we also use Sakai event log data, like for example, number of times a student logged into a Sakai session, a number of forums contributed by the student, or number of assignments contributed by a student. And we added partial contributions to the final course grade as recorded by faculty members using the Sakai gradebook tool. This actually ended up being a very powerful predictor, as you can imagine. We're also interested in testing how portable these predictive models were, in the sense of models that were trained and tested with Maris data, how these models would actually perform at institutions with completely different demographics, completely different retention rates. For this purpose, we used, or we partnered with 4 institutions, 2 community colleges and 2 historically black universities. We ran pilots on these partner institutions, 72 courses, more than 1,000 students per semester during the spring 2012 and fall 2012. The data that you have in the paper refers to spring 2012, really. Finally, we're interested in testing the intervention strategies, how effective these intervention strategies were on the students tested in these pilots. I'm going to very quickly now pass it on to my colleagues so that they can present results. I may die while I'm trying to get this out of me. Okay. I can carry it forever if you want.
Hello, everyone. My name is Sandeep Jayaprakash. Okay, better. My name is Sandeep Jayaprakash. I work as a technical analyst at Marist College under the guidance of Eitel and Erik, who's going to be presenting momentarily. I'm going to walk you through how we built the predictive model, give you more idea about how the early alert system looks like. This is a high-level overview of the work we are doing. This is our early alert system. We have 2 components. One is the predictive modeling component, and the other one is the intervention component, right? What we are trying to do is identify who are the students at academic risk and by what factor, right? We roll out the probabilities of their failure. We were looking at four major sets of data, which comes from 2 major sources. One is the student information system, or banner, as we call it in Marist. Here we got more data, which gave us details about student background, social background, and some of his past performances, which is the student attitude data. Here we're collecting his current GPA as it stands and his aptitude scores and everything. So that gives us more direction to go towards like what his attitude has been and how he's been performing in the past. And later we look at the demographic data, which is more social in nature. And once again, we keep a track of Sakai gradebook, which is more dynamic in nature because it keeps changing throughout the semester, while the SIS data is more static in nature. It doesn't change over the semester. Whatever we collect at the beginning of the semester, it stays the same, right? Once we have all these 4 kinds of data, we have extracted these data. We find a way to kind of mash all the data together, marry them together, you know, so that we get like for each student course combination, we can have like a series of predictors we can participate in the prediction process. We clean up the data after we have combined them, and we also derive like powerful metrics through the process of aggregation techniques. Like, for example, number of times he has opened the session, right? For a particular class, we calculate what's the class average, like what's the requirement, and we kind of take a ratio of where the student stands against that particular class average, and that's a powerful metric. We do that for each and every metric we collect in the Sakai events. It can be forum postings, number of times he has submitted an assignment, number of times he has submitted an assessment, number of times he has just read a content. So we take a ratio of his performance against the class average. And that kind of is a very good, powerful metric which can actually give us more direction in terms of where he stands in the class. Right? Once we have this kind of data, we feed it into the predictive modeling stage where we train predictive models, find correlations between each of the metrics we have actually created in the ETL stages. Right? Here we use 3 machine learning algorithms, logistic regression, support vector machines, and J48 decision trees. Once we have the predictive modeling stage, the outcome of the, once we have trained a very powerful predictive model, what it can do is it can identify who are the students at risk and give us like a probability of the failure, right? Once we have that data, we forward that particular information to the faculty members. We don't forward the probabilities to the faculty members. It's more like we categorize them as who are the high-risk candidates, who are the medium-risk candidates, and who are the low-risk candidates. And we forward that information to them so that they can have suitable intervention strategies and kind of impact on their retention by boosting their performances. So let's take a look at the experimental setup which we had at Maris. We use Pentaho Kettle for data integration purposes, for extraction, transformation, and load purposes. We basically were looking at 3 semesters worth of data. We reserved 2 semesters worth of data for training purposes and 1 for completely testing and validation purposes. So like I said, we extracted the data sets, joined them, cleaned them, recoded so they are more data mining friendly, and we also derived like powerful metrics through aggregation for each of the semester data. So these are some of the predictors which we've been using. It's an interesting mix of all the student past performances and the current performances, which helps us predict like what the future looks like, right? We have gender, SAT scores, scholastic aptitude test scores, and any other equivalent aptitude scores. It may be ACT scores, or I don't know, for graduate students maybe GRE, etc. And you have your full-time, part-time status, like whether they're a full-time student or a part-time student, and what class he belongs to, whether he's a freshman, whether he's a sophomore, junior, senior, right? And what his current cumulative GPA looks like, what's the size of the class in that particular course. And we also look at like what the university thinks the student is currently in, like what's his academic standing like, whether he is in probation, whether he's a Dean's List student, right? That kind of data. And the RMN score is a derived metric, like I said, a ratio of how he's performing against the class average. And similarly for the R underscore sessions, that is like a ratio for sessions and number of times he has read the content and etc. Our target is to find like who are the students at academic risk. That is denoted by 1. So once we have this data set, we took the data mining softwares like Pentaho, Weka, and IBM SPSS Modeler for validation purposes. IBM SPSS Modeler was completely reserved for validation purposes because we wanted to keep it open source. Okay, well, we took the training data set and we generated like 10 data sets by varying the random seeds. And later we had to balance the data set because there's a lot of imbalance. Like there are like 95% of students who are good standing, and there are like 5% of students who are at risk. So we had to bring this number up so that the model doesn't have any bias, right? We trained the predictive models using these 3 algorithms. So all in all, we have like 10 data sets and 3 algorithms. So we have 30 models. And we tested this against, we predicted the results on Maris fall 2011 data, which were reserved for testing purposes. And we checked out like how the accuracies and other performance metrics look like. And we produced a summary of measures by calculating the mean and standard error. Right? This is one of our predictive modeling flows in Waker. It's pretty much what I explained, but it's in a more clumsy way. So what you see here is a pre-processing stage where we are feeding the data into the standard set of machine learning algorithms and coming up with the outcomes. So let's take a look at like how the results look like. In terms of accuracy for all the three machine learning algorithms we have been using, we are hitting a consistent mark of 85 to 86%. And in terms of recall, which is the ability of the model to identify at-risk students, we are isolated that population, so we wanted to check if there was a bias in the model, right? Because accuracy alone cannot be a very good metric, because it's totally biased by the number of students in good standing, or at least that's the case in Maris. So if you see the numbers, we are still hitting like 80% in terms of two of the algorithms, and J48 was kind of bad, it was off. And specificity and precision give us more direction towards like how many false alarms we are raising. So far in terms of specificity, we have been in a very good range, like 85, 86%, and there's a good balance between accuracy, recall, and specificity, right? Once we had trained this model, we wanted to see like how it performs in a totally different academic settings. So we kind of partnered up with, sorry? Oh, okay. Okay, sure. Okay, I'll keep it a little short. We partnered up with a bunch of community colleges. We extracted the static and dynamic data, fed it into the model, and got the academic alert reports out. And we hosted that academic alert reports in the project site so that the faculty can pick these reports for their respective courses from the Dropbox. And they administered the, suitable intervention strategies for each of the students who was identified as at risk. So this is a sample of the academic alert report. Here you see that we are categorizing the students into high, medium, and low risk candidates. So let's see how the models performed at the community colleges. We basically rolled out these predictions at like 25% into semester, 50% into semester, and 75% into semester. And as you can see, the accuracies kind of increased from 60% to 80% range, and it's a similar kind of trend in terms of recall and specificity too. We see an increasing trend as the semester progresses because we have a lot of data available. So what does this tell us? The models are more portable than we actually thought. Initially we thought this wouldn't work. We thought probably we are lucky if we get like accuracies of probably 20%. But 60 is not bad. That's a very good starting point. And we have been reaching 80% as we progress in the semester, at like 75% into the semester, right? So it's like a very good starting point, and we know that the model works in a totally different academic setting. And similarly in the recall, we can see we are hitting like consistent 70%, which is just like 10% of what we found in Maris. So the models are really portable, and in the long run, probably we can have like a customized model which can be built for each of the university, keeping this model as a base. And we have found that the gradebook and the cumulative GPA have been very important predictors, and there's a good evidence of portability in institutions collecting this kind of data. I'll forward it to Erik so that he can talk more about intervention strategies.
Okay, hi everybody. I'll try to move through this quickly. So I'm going to cover the intervention end of things. So once this at-risk students were identified, we went ahead and implemented the system to identify the at-risk students through the techniques that Sandeep had described. And so this involved 3 different institutions. A total of 1,379 students were included. We had 3 groups to provide comparisons. 1 control group that didn't receive any intervention, an awareness group, which I'll describe in a minute, and then what we called our online academic support environment group, which had a more intensive intervention. So at 3 different points during the semester, we provided an academic alert that was basically the notice that they were in trouble. That was forwarded to the instructors, and the awareness group got the messages. It had some language that attempted to provide a sense that their instructor was paying attention to them and they really needed to do something to change their course. Then there were additional services that were requested that were provided by the instructors. A bunch of typical things that instructors might do if they were to encounter a student who was in trouble. The OASIS group got similar interventions and then access to some additional online resources. Basically, at the end, we collected the data from, and I'm about to present the first comparison was an ANOVA across these 2 groups, 3 groups, and basically what we found was that the 2 intervention groups did not differ, but we saw that they had considerably higher GPAs than the control group, or significantly higher. We also used non-parametric assessments as well, looking at frequencies, and again we saw the collapsed treatment groups differed in terms of their content mastery, defined as a C or better. Interestingly, we also looked at withdrawal rates, and we found that in the intervention groups they had a higher withdrawal rates, which at first seemed a little contradictory, but it meant that they were aware of the fact that they were in trouble and they had an opportunity to do something about it and get out of the course before it landed on their transcript. We did the same kind of comparison, collapsed against for the at-risk students, and again we found that same kind of difference in an ANOVA. And basically what we learned is that the treatments, both of the treatments, outperformed the control groups, and they had higher rates, of course, withdrawal. And there was 3 academic alerts that were provided. It was really the first that was most important. And so we asked these questions: why does this help? Well, we feel it's important that these students get early feedback so they have an opportunity to change their course. Despite the poor grades, these students may not even know they're at risk, so early on it's important to identify that. And then these classes were often fairly large classes, and so what we feel is that in particular with these large classes, the instructors wouldn't have an opportunity to provide an intervention that they might receive in a smaller class, and so this strategy is particularly effective when we're dealing with that population. So I guess we don't have any time for questions, but thank you.